Today we will talk about how to alter our tables and how to place some constraints on our tables and columns. I will start this session as an admin because I want to do something a little bit with schemas. So I will type my password is MonetDB and then I will create two sample tables. First sample table is table turnover, and I will insert some data inside of this table, and then we can read from this table. This is a really simple table with 4 columns. Now this first column ID already has a constraint primary key, and this last column turnover has a default value and it cannot be null. And then we will create one more table. This other table will have a name table cost. Again, I will insert some data inside of this other table, and then we can read from this second table, and this second table is almost the same as this first table concerning data. It doesn't have any constraints except this constraint unique, so the values in this ID column has to be unique. So these are our sample tables. I will now clean my screen. We can alter our tables in many ways. First, I will rename this table turnover to be called table income. If we want to read from this table, we now have to use this new name. So if we read from table income, we would again get our old table. We can also notice here that I have a column turnover. I also want to change the name of this column to income. So again, I will use alter table statement. This time I will rename column turnover to income. I will run this, and then if we read from our table, we will see that our column turnover is now named income. We also saw previously that we have a constraint on this income column, that this column doesn't accept nulls, but we can change that. If we use alter column income set null, then this column will be able to accept nulls. We saw in some of previous videos that we can make our table read only, but we can also make it insert only. So I will make my table cost insert only. I will run this, and now we cannot delete anything from this table. If we try to delete something from this table, we would get an error. Next, we already saw that this income column has a default value 100. We can change that. Again, we will use alter table statement. We will alter column income. We will set default value to be now 200. And we can also delete this constraint. So we will alter table income. We will alter column income. We will drop default constraint. Next, we will create a new column in our table. And this new column will have a default value 88. I will run this, and then we will read from this table. And we will see that all of the values in this new column are 88. If we haven't provided this default value, then we would have nulls in this new column. And because we don't need this new column, I will delete it. For that, we will use alter table cost drop column new column. I will run this, and now our column is deleted. Next, we will see how to change a schema of table cost. So I will now change the schema of this table to VOC. Currently, the schema of this table is a default schema for admins, and that would be C schema. But I will change that to VOC. I will run this. Then I will set my current schema to be VOC. And then we can see what tables do exist in this schema. For that, we can use \d command, and we will see that inside of this schema, we have VOC table cost table. And then we will make this table to be inside of C schema again. So again, I will apply this alter table set schema C statement. we will change back our current schema to sys. And again, I will check what tables do exist inside of this schema, and we will see only our two sample tables, table cost and table inc. I will now clear my screen. Next, we will see how to delete primary key constraint and unique constraint. In order to delete these constraints, we need to know their names. And we know that in the table income, we have a primary key constraint on the ID column, and in the table cost, we have a unique constraint also on ID column. We will start our search for the names of these constraints by reading from sys.tables system table. We will search for our tables, table cost and table income, and we will find that IDs of our tables are these two numbers. Then we will filter sys columns table by these numbers. So we will only look for columns from our tables, and we will also search only for columns that have a name ID. And if we run this, we will find that IDs of our columns are these two numbers. Now that we know that, we will read from the table dependency columns on keys. So this is one system table where we will search for our constraints, for our primary key and unique constraint, by using IDs of our tables and IDs of our columns. I will run this, and we will finally find the names of our constraints. We have this unique constraint, and we have this primary key constraint. I prepared one statement that actually combines all of these statements in one. So this is that statement. This statement will join sys tables table, sys columns table, and dependency columns on keys table in order to get the names of these constraints. I will run this, and we can now directly see that this is the name of our primary key constraint and that this is the name of our unique constraint. Now that we know these names, we will delete them. And for that, again, we will use alter table statement. So first, we will delete this primary key constraint by using drop constraint and then the name of a constraint. And then after that, we will delete unique constraint. Again, we are using alter table. And this is how we can delete our primary key and unique constraints. I will now clean the screen. Primary key constraint and unique constraint can be placed on several columns. I will now create one new table, and in this table I will place primary key constraint on two columns and unique constraints also on two columns. So if I run this, this will be successful. But we can also add primary key on several columns on the existing table, and for that again we are using alter table statement. This time I will place primary key constraint on table income, but I will use two columns, ID and sub ID. And we can also do the same with unique constraint. I will place unique constraint on table cost on again columns ID and sub ID. If we now read from our system tables to find out the names of our constraints, we would get this result. Now we have 4 rows because inside of this income table we have primary key on 2 columns, and inside of cost table we have unique constraint on 2 columns. I will now clean my screen. If we do not provide a name for our constraint, then Monet will generate that name. And it will create a new name by concatenating table name, column name, and constraint type. So we would get something like this. So this is the name of a table, this is the name of a column, and this is constraint type. And this is how we can be sure that we have a unique name. If our constraint encompasses 2 columns, for example, ID and sub ID, in that case, instead of our constraint name, we will have names of both of those columns. Now, if we want to give a custom name to a constraint, and if we are creating a new table, then we can use syntax like this one. We would say constraint, and then our custom name, and then definition of a constraint. So if we run this, this is successful. We can do the same on the existing table. So here I will add constraint with a custom name to our existing table, but this will fail. This will fail because one table can only have one primary key constraint. So in order to add this constraint, I first have to delete the old one. So I will first drop constraint and then the name of an old constraint. I will delete it, and then I will create a new constraint with a custom name. And we can do the same with unique constraint, but unique constraint is different because we can have as many unique constraints on one table as we want to. For example, I already have a unique constraint on this table on these columns, but I can create another one. I just have to provide a custom name. I will run this, and now we can check our constraints. We will read from our system tables to see what constraints do we have. And here we can see that we have three constraints. We have old unique constraints which we haven't deleted. Then we have a new unique constraint with a custom name, a new primary key constraint with a custom name. Notice here that I also have a new column key type, which will tell me which constraint is unique and which constraint is primary key. 1 means that this is unique constraint, and 0 means that this is primary key constraint. If we read from one other system table with the name sys.keytypes, we will see those values. So 0, 1 are here. 0 is for primary key and 1 is for unique key. And we have some other constraints. I will now clean my screen. Next, we will talk about foreign key constraint. I will jump here to this web page, and here we can see that in Microsoft Excel, we can create a list of values, and only those values will be allowed to be entered in some other column. For example, in this column here, we can only place quarters 1 to 4 because only those values are listed here. And such limitation in Excel is called data validation. We can do the same thing in database. First, we need a table which will be parent table. Inside of that table, we have a column which is a primary key column. And this column will list values that can be used in this other table. So this column here is the same as this column here in Excel. This other table is called child table. It has a column that is called foreign key column. And inside of this column, we can only place values from this column here. So this column here is the same as this column here in data validation. We can see that better on this image. We have a parent table with primary key column, and that column will limit values that we can place inside of this foreign key column inside of child table. Let's now go back to terminal, and I will now create a new table that will have foreign key constraint. We have created foreign key constraint with this name, and this constraint will be on these two columns inside of our child table. And in those columns, we can only place values that do exist in the parent table. This is parent table in the primary key of this parent table. Let us now see how we can find data about our foreign key constraint. For that, we can read from our system tables. For example, we can read from this system table sys dependency keys on foreign keys. And here we will find that tab 2, which is a parent table with this ID, has the primary key constraint with this name, and this is ID of that primary key constraint. And this primary key column will limit the values that we can place inside of this child table. This is ID of a child table. This is ID of that foreign key constraint that we have just created, and this is the name of our foreign key constraint. If we want to find what columns are part of some foreign key constraint, then we can read from this describe foreign keys system table. And here we will see that this is our child table is tab 3. Foreign key columns are col 1 and col 2 inside of a child table. The name of this foreign key constraint is like this. And primary key columns are col 1 and col 2 inside of a parent table tab 2. Now we can combine these two tables by using one select query, and this select query will give us all about foreign keys on our child table. So here we can see that our parent table is this one. These are the columns in the parent table. This is the name of a primary key constraint on these columns. And these two columns are limit the values inside of these two columns, inside of a child table, and such constraint will have this name. Let us now create the same foreign key constraint but on the existing table, and for that we will use alter table statement. So we will use table cost as a child table. We will place constraint on this column inside of a child table, and the values for this column must be already present in this other column inside of a parent table. And I will run this, but this will fail. Why? Because in this parent table, this column here is not a primary key. So we have to use columns that are part of a primary key or of unique constraint. In our parent table, we need two columns for primary keys, so we will modify this statement. Then we will run a statement like this one. Now we have two columns because these two columns are actually primary key for parent table, and we will use them to limit the values inside of a child table. So I will run this, and this will work. We'll now jump again to this web page, and now we have a foreign key constraint. And now inside of this child table, we cannot enter any other values except the values that do exist in the parent table. And also it is not possible to delete a row in the parent table because that row is referencing the row in the child table. Let's see that. I will now try to insert a value inside of child table that do not exist in the parent table. For example, these two values do not exist in the parent table. So if I run this, we will see that this is not allowed because this is against a foreign key constraint. And similar to that, if we try to delete a row from the parent table, this will not be allowed because this row is referenced in the child table. I will now clean my screen. In the table cost, we have column ID. I will try to delete this column, and I will fail because this column is part of a foreign key constraint, and it is also part of a unique constraint. Next, I will try to delete primary key constraint in the income table, and this will fail again because we have used this primary key constraint as a part of our foreign key constraint. But I can make these two statements successful if I add this cascade keyword after statements. For example, after this statement, I will add cascade, and then this statement will be successful. I will roll back this transaction because I don't really want to delete primary key constraint. And the other thing is that we can also use cascade after this statement, and in that case we would delete our ID column and all other objects that are dependent on this column. Next, we will talk about how to handle nulls. I will first try to insert null in a column that is part of a primary key. So these two columns are primary key. I will try to insert null in the ID column, and this will fail because, of course, we cannot have nulls in the primary key column. Next, I will remind ourselves of the tables cost and income. We can see that inside of this column, in the table cost, we have two nulls. But in the income table, in the same column, we have only one null. And I will now place unique constraint on this column in the income table. So I will run a statement like this one. And here I will apply unique constraint with subclause nulls not distinct. This means that if we have two nulls, they will not be distinct, so they will be the same. That means that we will have a duplicate, and this will make this unique constraint to fail. But in this case, this will succeed because we only have one null, and single null is not a duplicate. On the other side, if we apply the same constraint on the cost table, and in the cost table we have two nulls. We have null here and null here, and they will be considered as duplicates. So in this case, this statement will also succeed. And this is because this constraint will not be affected by the existing values. Only when we try to insert new nulls then this constraint will come to play. So for example, if I now try to insert a new null beside this one in the income table, so if we try to run a statement like this one, I'm inserting a null in this column, so I will have two nulls. In that case, this will fail because only now our constraint will be effective. On the other side, beside this subclause nulls not distinct, we have subclause nulls distinct. And this subclause is default, so if we just use a unique without any subclause, then this value will be valid. And in that case, we can have several nulls in a column. It doesn't matter because they will not be considered as duplicates. I will now clean my screen. When we are creating a foreign key constraint statement, we can place some special subclauses in that statement. I will now go here below and I will show you those subclauses. We can see them here. So we have match simple, and according to SQL standard, beside match simple, we can also use match full or match partial. Then we have on update restrict and on delete restrict. And according to SQL standard, beside restrict mode, we can also use no action, set null, set default, or cascade. Now, all of those other options are not supported in Monet. So in Monet, we can only use these default values. So these subclauses are not really useful in Monet, and we shouldn't use them explicitly. But I will explain their meaning. First, I will talk about on update restrict and on delete restrict because those subclauses are really simple, and we already saw the effect of these subclauses. If we have a parent table with a parent column and a child table with a child column, and if there is a foreign key constraint between them, we cannot update or delete rows in the parent table if they refer to some rows in the child table. So that is the default behavior, and that is the meaning of these two subclauses. On the other side, what is the meaning of match simple? Well, when we have foreign key constraint, we will check whether some rows in the child table violate that constraint. But if rows, that is foreign key columns in the child table, has some nulls, for example, we can have a null in the first column, or we can have null in the second column, or in the both columns. In that case, those rows will be excluded from the check. So we will not check such rows for foreign key constraint violation, but we will just ignore those rows and we will consider them as valid. At the end, I want to tell you that when we create a table, we can use if not exists subclause. So we can use this, and this will help us to avoid any error. So we will create new table, but if such table already exists, then we will not do anything, but we will get this message operation successful. We will not get an error. And that is the function of this subclause if not exists. And similar to that, we have if exists subclause in the alter table statement. So this alter table statement will change this table if it exists, and if it doesn't exist, again we will just get operation successful message. There will be no error.